So what we're going to talk about today is AI really that useful? And of course the answer is yes, because we've already joked about this. If it was no, this would be a pretty short lecture, I guess, right? So before we get started, this is going to get your fingers dirty talking to robots. So I'd advise you to pull your phones out, look for the Wi-Fi cyber camp, and password here. Some of the tools that we're going to explore together. We're going to look at ChatGPT. We're going to look at Google Gemini. We're going to look at Perplexity. We're going to look at Google Notebook LM. And we're going to look at Google Gemini 1.5 with deep research.
Here's what you need to know.
Oh.
Features. Generative AI can create text, code, images.
My own robot's talking to me. It's very nice. So real quick, is anybody, let's start from the bottom up. Has anybody played with deep research yet with Google? No hands, good. Has anybody played with Notebook LM from Google? A couple people, okay, excellent, good. Many people played with Perplexity. A little bit more, okay, good. What about Google Gemini or ChatGPT just in general? Okay, all right, good. So is everybody on the Wi-Fi? I was going to move slides, but I want to make sure everybody's got it. Okay, we can come back if necessary. All right, so the overview, we're gonna quickly go through just how we got to now. I did this lecture last year. I condensed the slides. I don't want to spend too much time on the technical parts, but I want to level set and do just a little bit of what are these large language models, how are they trained, just some of the useful facts so that you've got kind of a mental model of what's going on when you start using these models, okay? Then we're going to get into just engaging the large language models themselves, a couple use cases. We're going to discuss the risks. And then some of the ways that these companies, these large labs, are overcoming some of the risks of just engaging directly with a model. And two of those would be retrieval augmented generation, or RAG. You'll hear RAG a lot if you start getting into the AI workspace. And reasoning models. Those are processes layered on top of these language models that address the risk and actually make them more useful for us today. And then at the very end, I'm going to give you some additional resources that are kind of shaping my thought or what I'm consuming in the AI space since it's changing super quickly. I'm going to give you the bottom line up front. Here's your key takeaways that I hope you get out of this practicum that we're doing here. Generative AI, it's accessible. Even basic interactions can be very powerful. Once you start using it, you're going to see it. I'm going to encourage you to invite it to almost every conversation. Not every conversation, but those times when you're in kind of like thought mode or anything else, invite the robot to the table and just engage it in conversation and see what it does for you. Prompt engineering matters. Okay, you've got to give real good context if you want to get good answers. If you ask bland questions, you're probably not going to be very impressed with the results that you get back. But as you get more into it and you start working and you see how prompts can be properly crafted and you start directing it with more context as to what you're really looking for, what it does is it emerges and it renders and services good results for you. These tools can enhance productivity and creativity. It's not about replacing humans, but augmenting our abilities. The future is bright and very unpredictable. This field is crazy rapid. Nobody even knew what DeepSeek was 3 days ago, and now everybody seems to want to talk about DeepSeek. We'll actually talk about that here in a minute. And then the number one takeaway, I want you to do this. This is the number one takeaway, is the very last one here. Just start using it. Don't be afraid of it. Even if you don't know how to prompt things properly and you feel like, I don't even know what to ask, just start. Just start and just have follow-on questions, and you're going to see that all of a sudden it's going to be ingrained in the way that you start developing your ideas. Okay, so let's level set just a little bit. We're going to talk about AI in general. So when you ask Huntsville as a community and you say, well, what's going on with AI? A lot of the companies here in Huntsville get a little offended because they say, we've been doing artificial intelligence for the last 20 years. Okay, and if you're not familiar, if you're not from this area, Huntsville has a massive Department of Defense presence, Missile Defense Agency. We've, all sorts of things where we're looking at target recognition. And so what I want to differentiate here is that Huntsville and a lot of people have been doing discriminative AI for a very long time. And what discriminative AI is basically yes, no, right? Is there a dog in this picture? Yes, I can identify that dog. Success. That's what discriminative AI is. Is that a target or is that a piece of clutter? Is that, so Doing discriminative AI, is that a stop sign in the picture or not? We all see those as kind of like the are you a robot test or not, right? So those would be examples of discriminative AI. But along the way, with some changes to the, they use deep neural nets and deep learning to do kind of the discriminative AI that they're talking about. But when we start talking about generative AI, it turns out that if I've got a lot of photos that have been tagged, and I know what a dog is, and I start just tagging everything in photos, and I build this giant corpus, or the semantic meaning of what's going on in all these pictures. And lo and behold, we get a new model architecture in 2017 called the transformer model. We can start taking these concepts and we flip this on its head. Instead of like 1,000 tests of, is there a dog in this picture? Is there a stop sign in this picture? If there's a mailbox in this picture, we flip it on its head and we say, can we generate based on all the tags and the data that we know that it is? You turn it around and you say, create an image of a dog having fun at a party, wearing a black tuxedo with wine in one hand. This photo has never been created before in the history of mankind. But it took a language model, it took a lot of this type of work to figure out what a dog is, what fun means, what a party is. So all the semantic meaning of all this to render a realistic photo. So that's what generative AI. It's taking what we've learned, compiling it differently, and we're generating new. So it's inference. We're trying to predict the next token. We're trying to create something new based on the way you're engaging it. So how are these language models trained? So basically, they take all this unstructured data, which is everything ever written, right? Think of any book, any text, anything on the internet, Wikipedia, you name it. If it's got text, at first everybody thought, boy, this is just a bunch of unstructured data. We don't know what to do with language, but it turns out language has a lot of encoding buried underneath it. So what they did is they said, we're going to take a bunch of parameters, and I thought that the Booz Allen panel did really well today, saying it's basically inputs related to outputs, and the number of parameters in between is where you're going to be able to find a lot of different signals or correlation, or how well inputs and outputs are related to one another. So they make massive models, and what they do is they play the hide the word game. Okay? As an example, we know what truth is. We know what the sentence is. The cat is eating some food, period. And they mask one word. And they run the model, and they say, all right, predict what that masked word should be. And the first time they run the model, it comes up with the word painting. The cat is painting some food. Well, that's not realistic, right? So they say, that's not right, run the model again. And so next time it says the cat is baking some food. It's still a semantically correct sentence, grammatically correct as well, but still not what truth is of what they know. Third time they run it, the cat is chasing some food. Again, correct, but not what they're looking for. Finally, the cat is eating some food. But you end up with this probabilistic prediction of what that masked word is. And that's all these language models are doing. As a matter of fact, they don't even know what words are. These language models have no idea what language is. The very first step, and this is getting kind of deep into the details, is they've got tokens. They've got a numeric representation of every single word, 80,000 words in the human language. I don't know, 100,000 words in the human language. They're all represented by tokens, and it's just looking at mathematical relationships between tokens. It doesn't even know what words is, but it knows when to render the next token and how to make it make sense. When you convert it back to words, it all makes sense to us. That's the hidden patterns that are just buried within our language, and that the larger and larger models are pulling out for us. Okay, so let's talk about, we just covered this upper left quadrant, which is they did a common crawl. That's what they've all did. They stole everything off the entire internet, every book, anything that had text associated with it. They used it to train, okay? And training, playing the hide the word game, okay? And it's a little more complicated than that. But that's what we call a pre-trained model, and those are the foundation models that you hear of, right? So when you hear in the median, they say GPT-4o, what they're talking about is they're talking about a foundation model. When you hear Gemini 1.5, it's a foundation model. When you're hearing Claude Sonnet 1.5, all of those are just foundation models. And the beauty of what they've done is that they've compressed, it's a big compression algorithm. They've taken all of the human knowledge and they've compressed it into a set of numbers, a set of weights, that it's 200 gigabit, GPT-3, I think, was 200 gigabytes. You could store that on your iPhone. You can't run it on your iPhone, but you could store basically all of human knowledge in 200 gigabytes, because you could query it and you get answers back out. So what they've done, it's a big compression algorithm. I don't know if people are familiar with what a JPEG image is. A JPEG image is just a compression algorithm that takes, instead of like storing every single value of every pixel in an image, it learns that there's a transformation you can do, and I can store that same information in 10% of the variables. And then I can just reconstruct the image based on, so it's a big compression. I can just store the weights of the JPEG algorithm as opposed to saving all of the pixels. The exact same thing's going on with these pre-trained models. They can render almost all human knowledge. They can recreate the ideas, the concepts, the semantic meaning that's embedded in the model. But we aren't engaging with this. Okay? So what they do is they've got to go through this feedback loop right here, which is supervised fine-tuning and reinforcement learning with human feedback. And now there's actually more complicated ways to do that, but the OpenAI model is that they use reinforcement learning with human feedback. So what they would do is they would come up with curated prompts and responses. A question, can you, why is the sky blue? And then the language model would do 10 responses, and they would actually feed it to a human, and a human would go, that one makes the most sense. And then they would score it higher. That was the reinforcement learning part. And so over and over and over and over and again, there's this element of human reinforcement learning. So these models actually are built to please us with their answers. They want to sound intuitive. They want to sound clever. It's because that we've had this part of shaping the model, and it actually can go in and tweak some of the values in the model, but up in the upper layers. But this is where we end up with the chat assistant. Most of you use the chat GPT. This is the part that we interface with. This is the part, right, historically, that cost millions and billions of dollars. All the NVIDIA GPUs are going to do the foundation model training. Not so much initially on the answers that we were getting back. It was one-shot token prediction, so it was pretty small. We're going to talk about, once we get into reasoning agents, now they're applying the GPU chips to inference time, so they're scaling in a different dimension. Point of this slide is they've taken every bit of the data that we've ever created in humankind in written text. They've done pre-training on it. There's not much more raw data out there for them to learn on. They go through some sort of refinement mechanism, and then they end up with these chat assistants that we actually get to engage with. So this is the part we're engaging with. Okay, this is a very complicated chart that's showing you all the models that are out there. Foundation models, reasoning models. I'm going to spend about 2 seconds just to show if I can open this. Yeah. So it's pretty interactive here, and you can see these are all the main players up in the upper left. So you've got Anthropic, you've got the Chinese models, you've got Google, Meta, Microsoft, Mistral, OpenAI, and then other. And if we click on Anthropic, for instance, you can see their models, and the size is the number of parameters that have gone into their training model. You can see that they're already up at 90% of the humans. Performance-wise. They're already getting a 90 when you judge them relative to all humans. The other thing to point out is you've got large models, but look what's happening. Some of the higher performing ones are scaling back. That says that there's a lot of redundant, maybe garbage information inside if you took the entire corpus of everything ever written down. Man, if you look at the comment section in Twitter or anything else, I don't know if I would want that, or Reddit. I don't know if I'd want that in too many training models, right? So it turns out that if you curate the information going in, you can get away with building much smaller models. The ones we're going to be working with today, so if we look at OpenAI, you see they're still, the O1 reasoning models are still the highest performing. Most people are still engaging with this GPT 4.0 and getting really good results. And so, again, this is a link that's kind of fun to see how the language models are evolving over time. Okay, time for our first exercises. So, does anybody know what semantic search is? Great. Everybody pull out your phone. Humor me just a minute. Go to your photo app. Whatever you do that stores all your photos. It used to be that when you wanted to go find a photo, you'd sit there and thumb through it and go, God, was that 2017? Was that 2016? And you just thumb and spin and thumb and spin. Guess what? They've got semantic search built in. Search for white shirt. Search for sunset. Search for soccer ball. Search for an object, or search for something that you were doing, and it now knows, due to computer vision and these language models with the semantic meaning, it'll go search your photos and pull them up for you. So I don't have to remember if it was 2017 or 2016 that we did that. So we already have semantic search built into our phones. Okay, so that's one very easy example of a way that to engage. It's already there. Okay. we're about to start using OpenAI, ChatGPT. I'm going to open up a window and sit down right here. But first, if you don't have these apps loaded on your phone, I want to volunteer. Is there a volunteer? Yeah, okay. So think of a concept or a topic that you've heard today that it didn't quite make sense. And feel whatever it was. Is there one? Nothing comes to mind. Does anybody have one? Does anybody have something that was like today, I heard this and I don't quite understand what it means?
Semantic search.
Semantic search, perfect. Okay, pull your phone out and put it on speaker so we can all hear it. And go to the phone and dial 1-800-CHAT-GPT.
Hi, I'm ChatGPT, an AI assistant. Just so you know, our conversation may be reviewed for safety. By continuing this call, you agree to OpenAI's terms and privacy policy. So how can I help you today?
Ask her to explain. What is semantic search? There you go.
Semantic search helps find information based on meaning, not just keywords. It understands context and relationships between words, aiming to deliver more accurate and relevant results.
There you go. So I mean, if you're ever bored, and like, I use this for my parents, to be honest with you. You know, they call me still to ask questions about something, and I know they're not going to download the app. They don't quite understand it, and so I started saying, "Mom, have you dialed 1-800-CHAT-GPT?" She was a little offended at first. She's like, "Why won't you help me?" But I was like, "I want you to see how these things can help you. Ask your question first, and come to me second." So anyway, you've got access for free. It's a 1-800 number. It's free. You could just call 1-800-CHAT-GPT, have a fun conversation. It's a little bit fun. But it's more fun to engage it on your laptop, on your phones, everything else. And so here's what we're going to do. We're going to do the first thing. These models are very good at straight answering questions. So historically, Google comes along. They index every single website ever created, and we search, and they render websites to us. And we thought that was the coolest thing in the entire world because we got information access. But what do you still have to do? You still got to click through them, and you still got to read, and you still got to find that needle in the haystack most of the time. Okay? And so what these language models do is they jump straight to an answer. Okay? And so let's see what that looks like. And I've got all my prompts over here, so I'm just gonna copy it. I'm gonna go over here and let's just put it in ChatGPT. And so the question that I'm asking is, name all the astronauts that were crew members on an Apollo mission and a crew member on at least one of the shuttle missions. So asking our museum folks, do we know the answer to that one? Right, I mean, it's kind of a hard problem, right? That's you're not going to pull, right? So let's see what the answer is, and then we'll ask our judges if they believe it. Okay, number one, I want you to notice how it looks like it's typing things in real time. Okay, so number one, do you guys recognize John Young as an astronaut? Okay, so John Young, I mean, it jumped straight to the answer. We didn't have to go click through. I mean, if I were to put that same question into a website, I got a DuckDuckGo. It says, great, here's Wikipedia, have fun. Right? So that's one of the benefits of engaging with these language models. They jump straight to the answer. We don't have to sit there and click and search websites anymore. Okay? The next one is about learning new concepts. Okay, and we're going to switch over and we're going to use Gemini this time. And I'm going to make sure that I'm on, let's just clean this out. So the question is please explain correlation and causation on a 5th grade level, because that's what it takes to learn it for the first time. So let's see what it's going to tell us when we say, teach me. Okay. Imagine you're at a park, notice there are more people wearing sunglasses when it's sunny outside. You might think, wearing sunglasses makes the sun come out. That's correlation. Those two things tend to happen together. But that's not exactly actually true, right? The sun causes people to wear sunglasses, not the other way around. That's causation. One thing directly, So they did it on a 5th grade level. I've got examples, my brother's one of these major Bitcoin people, right? We all know one of those. And he's explaining things to his kids, and his kids didn't understand one of the concepts, and they went in and they did exactly this. Hey, can you explain that on a 5th grade level? It did, it connected, and the 11th grader goes, oh, I kind of get it now. It can, teaching an 11th grader monetary policy. I mean, there's a lot of different things we can do to engage, okay? So one more, and then we're going to get to some fun to let you guys do some things here in just a second. Why is sunlight exposure the first thing in the morning important? If you listen to people that listen to Huberman all the time, that's what they want to talk about all the time. You got to wake up, you got to let sunlight hit you for 30 minutes, especially your retina. If you don't know why, I mean, if you're questioning why people are saying certain things, throw it into the robots and let the robots tell you why they're saying that, or they'll also tell you when they're blowing smoke, because I can do a follow-up question that says, is this really something that, you can start engaging with it, right? But it's just a great explainer because it jumps straight to the answers that you're looking for. So to me, the language models have turned into the great explainers, okay? Let's take it one step further. And we're going to do, I'm going to have to sit down for this one because it's a little bit longer. So I told you that if you start dialoguing with it, it becomes more and more useful to you. Okay, so I'm going to clear this out. I'm going to read you the prompts that we're going to use. Basically says, my boss has asked me to write an exploratory paper on space-based power sources that can be used on Earth. I'd like to end up with 3 options that range from achievable to far-fetched. To start the conversation, please create a list of 12 options for space-based power generation projects that can be delivered and used on Earth. So here it is on the achievable side. Space-based solar power, solar sails for concentrated power, lunar solar power. More challenging, orbital wind turbines, space-based nuclear reactors, asteroid mining for fuel, far-fetched, Dyson sphere, swarm, antimatter power, black hole power, zero-point energy, space-based fusion power, cosmic. So it did what we were asking for. That's a good list of 12. So I'm going to follow up with a question that says, for each option in the 3 different categories, please provide a rank order of the potential power generation for each concept. Provide a separate rank order of estimated risk for the approach. So I'm asking it to start doing some rank ordering and analysis for me. So in the achievable section, the rank order of the 3 for potential power generation, very high, high, medium, estimated risk, medium, high, low. Same with the medium. It gave me the ranks I'm looking for. It's very nice that I can export this to a sheet if I wanted to. And then the far-fetched, the risk extremely high in all of them. So it's about what we expected. But it's still not getting me to what I want to help me get what my boss asked me to do. So I'm going to follow up one more time. It says, for the paper, I'd like to focus on a solution from each of the 3 main categories. Please choose the option that are in the middle for risk and the middle for power. So it's got to go through now, and it's based on its order of ranking. It's got to choose one from each one of the categories and say, here's your 3 that you're going to do. So space-based solar power is the kind of middle for middle achievable and middle power generation. Orbital wind turbines, and then space-based fusion power is the far-fetched one. And it's like, okay, great, those all look nice. We say, please create an outline for a paper that lists all the options in the introduction, highlight the 3 chosen projects, provide pros and cons for each approach, provide a step-by-step guide of generating activities required for each approach, and estimate the benefit of each. Boom. I've got, it's generating my paper outline just from using it and dialoguing with it and have it kind of refine my thought and having let me be human in the loop, refining the ideas that it's generating to me. And so this is something that you could come down here at the very bottom, copy, paste into a Word document, start working on your paper.
How consistent is this?
Consistency? That's a great question. So, okay. Let's talk about consistency, because there is something, it used to be that they would let you play with the controls going into the language model, and there was one called temperature. And what temperature allowed you to do is, remember when we talked about all the words that fit into that sentence and there was a probability associated with them? The higher the temperature meant it gives like a more creative. It's going to open up the threshold that it uses in the probabilities, and it says you could take any word greater than 50% probability. And it had some really creative responses that were all over the map. But sometimes when you're doing something very technical and you don't want it to be as creative, you could dial that temperature down to 0, and it would just take the very top response every single time in the token generation. Much, much, much more consistent. So the way that the models took those controls away, but you can tell it now. You can say be more technical, or you can say be more creative, and it knows what that means. If you wanted to tell it to rewrite, say just be more creative, make it more concise, make it more technical. Use natural language to dictate how you want it to sound, and it'll interpret it and it'll go for it. So some of the things that you saw that there was some longer prompt sentences. These are some just ideas as to how to, what to ask for in your prompt. Okay, one of it is, start off by seeding it with the goal of your problem. Like I said, you've got to give it really good context if you want to get good answers out. Start broad and then narrow down. You noticed how I said, hey, generate a list of 12, in these 3 different buckets, and let me just kind of see what the space looks like. So start broad, be iterative and interactive, experiment with different prompts, ask for step-by-step explanations, explore pros and cons. I mean, that's another one. I mean, as soon as they say this, turn it around, flip it on its head, and say, well, tell me why it won't work. And it's just as powerful in terms of giving you the ideas as how to make a robust paper when you're writing it. Request examples, analogies, case studies, creativity, brainstorming, validity and cross-checks. Keep notes. This is one that a lot of people will forget because they get lost in their prompt. They start going, and then 30 minutes later, they're like, I forgot the original prompt that ended what I want. I use Apple Notes all the time, and I'm just throwing my prompt in there, and sometimes I grab the response and throw it in there just to capture, because I know that I'm going to go on this chain and just have a giant conversation, and if it's something that I want, make sure that you're copying it and throwing it and saving it somewhere else. Constraints, be reflective, iterate. So let's talk about the risks. That was us engaging directly with the language models, okay? Did you feel comfortable about some of the responses that came out? They read well, but what?
So, yeah, they did read well.
Right.
The question comes back to, like when ChatGPT first came out, I asked it to write my bio.
Right.
Right. And it was like totally bogus.
Right. Now, hold on. The paragraph sounded good
yes.
because the reinforcement learning by humans, it gave you something that sounded great,
Right.
but it was fake and false.
Totally bogus. Right.
Right.
Do the large language models, do they get fed prompts? Are they learning from the prompts that average people are making? Like the shuttle.
Yeah.
Is that going back in, and is your reaction to it going back into the?
Those are very good questions. Very good questions. So in order to train a model, you've actually got to feed it information, but then you cut it off at a point in time, and it goes through, because it spends 6 months churning through GPUs, right? So there is this outdated knowledge problem, or recency bias is what they say. So there might be a 6-month gap that you can't ask it about the presidential election, the historic models. Now, we're going to talk about what they're doing to overcome that now. So there was a gap. So that's quite part of your question. The other part was, were they learning? From the beginning, they were, 100%. But you can go into OpenAI and you can click on the privacy and you say, don't learn on my stuff. And it opts you out. Now, if you trust them, I don't know if they're going to do it anyway. I don't know. If you're paying for it, there's a little more controls. If you're paying the $20 a month subscription, there's more controls and you can opt out of more. The safest way, and I'm going to say this, if you're working on your company laptop with company data, be darn sure that you are asking, make sure your ID department knows what you're doing. Don't put any secure information, or don't put any, anything that you would be worried about being on the open internet. Don't put it out there. We actually operate through APIs. We work in the Azure environment, which is Microsoft, so we engage all of the APIs through all the language models through an API call, which allows us, we've got Microsoft's assurance that it's our prompt, our data, our responses. So there's layers to the protection. DeepSeek, where it's a model, the Chinese model that just came out. If you're engaging their model right now through their web interface, they're 100% taking everything that you put into it to put into their model. Right. They tell you that, and so it's just be aware, but opt out whenever you can, just to protect yourself is the way to do it. Hallucinations and false information, lack of contextual understanding. Sometimes you ask it a question, but you asked it too broad and it gave you a really silly answer. It probably means that you need to work on your prompt a little bit more. Outdated knowledge, we talked about that. Bias and discrimination. Got some mood lighting going on. This is nice. So bias and discrimination, where do you think that would come up in a model? Actually, I had a really good example last year that I used in this practicum. It was a headline from the New York Times. I want to actually have it. I wrote it down here because it was a fun experiment to look at. So the headline read, Afghanistan reaches accords widening access to the mobile phone business in Japan. And I said, what's the sentiment of this headline? And it said, neutral. And I was like, well, that kind of makes sense. That's what, you want headlines to be neutral. It talks about Afghanistan, it talks about phones, talks about Japan. You change one word. You change Afghanistan to the United States. So it read, the United States reaches accords widening access to the mobile phone business in Japan. And guess what the sentiment was? Positive. Okay, so you can see the inherent bias that's going on if you're asking the model to do classification, and just because it said we changed one word, we changed a country, Afghanistan to the United States, shouldn't change the sentiment of anything in that sentence. Change it from neutral to positive just by putting in the United States. So there's bias into what's going into that they have fed the model to do all these trainings. Just something to be aware of. They're getting better and better because they know that they're being evaluated on it. The large labs are, so the models are getting much better, but it exists in the data. What happens to the language, just our English that we're using? That reinforcement learning, if there's a subset of words, let's say that there's 80,000 words that are common in the human language, but only 20,000 of them get really used at these language models, are we collapsing our language down? Are we going to start losing words and losing vocabulary just because we're going to all start relying on the robots to tell us what we should be writing in every one of our papers, and our language becomes pretty homogenous? One of those unintended consequences that I think is pretty interesting to kind of think about. So anyway, I'm talking too much, and we're going to get into some fun things. So one of the ways to address the risk is by using retrieval augmented generation. And what a RAG database is it's basically you give it a database of truth. Okay, so if I'm working with if I want to work with policy documents within my company, I can dump those into a vector, what's called a vector database. And then what happens is you query, I can write in my same prompt, what is our leave policy? It takes that, it goes through a word embedding algorithm, turns your words into a giant vector of numbers. That giant vector of numbers gets sent over to the database, and it says, because this stores it as that same vector, and it says, what all is really close to this vector? We've got math that can tell us that. It grabs those chunks, it comes back, it puts it underneath your response. It says, here's the query that they asked, what's the leave policy? Here's 10 pieces of text from our policy that are kind of related to that language model, come up with a nice sounding response. And so basically, it grounds the language model in truth. Okay, so that's one of the ways is using a RAG is that it grounds it in truth, and it's not just trusting the language model. You got a question?
Does it matter like what the file formats are in the database? It could be JPEG or Word or images or anything.
Yes. Okay. Multimodal is kind of what you're getting at. If you video and audio and images of all sorts of nature and different databases and different they're growing what you can put into the RAG on these, and we're actually going to talk about it first. So who's got Perplexity? If you go to perplexity.ai, so everybody pull out your phones. Let's all get comfortable doing this, using the tool. So if you go to perplexity.ai. Perplexity should look like this. So what Perplexity is they've created everything on the internet, that Google had indexed. They turned it into a vector database. Okay, so you're able to query against it, but it's gonna show you all the sources that it's using to make its response. So you can go validate and verify yourself. So it kind of overcomes that trust issue. And so the prompt I had for this says, I'm performing a competitive analysis for market research for my exercise app. What are examples of marketing campaigns from other exercise apps that focus on body weight exercises and weighted sandbag carries and elastic band exercises? My app does not focus on exercises that require expensive gym equipment. I just completely made this up. So what is nice is that it's giving me quite a bit of information, but you see all of these. I can click in and I can go and I can see exactly what the source of information that it came from. So everything is indexed. Number 2, it's from Fitbud. So I mean, it is showing you all of the reference information that they are using to give you your answer. So you can go validate it and you can trust what's coming out. But you can continue it. This is what's really good about Perplexity is you can continue the dialogue. And I say, what companies should I use in my competitive analysis? As a follow-on question. It says Nike, Freeletics, 7, Fitbod, all SWOT kit, caliber strength training. So 10 pretty good references right there that I can dig into and I can see what they're going on. And then finally, I basically tell it there's no way I can compete with Apple or with Nike. Say there's no way I can compete with the big companies like Nike and Apple. Focus on the smaller app players. I like the idea of gamification and challenges that they mentioned previously. What are examples of strong marketing campaigns based on the gamification and challenges that are related to the focus of my app? And you can see my grammar doesn't even have to be perfect. Just throw it in there and let it render. And they give me some good ideas. The Dare to Be Free campaign, 7-minute challenge, body weight focus. So anyway, start having dialogues, and it's giving you all the sources to play with that. So let's move on to probably my number one favorite app to use right now for learning anything. Okay, it's Notebook LM. And this is one where you guys are going to actually, I'm going to show you some examples, but we're going to play along and we're all going to do one together. Okay? So let me show you one first as I trip over the chair. So if I go to Notebook LM, you can see I've got quite a few notebooks saved down here. I had a trip to Portugal in December, and it was the first time being in Portugal, and I knew nothing about Portugal. But everybody said, you got to go taste port wine up in Porto, from the Douro River Valley. And I was like, okay. I said, I'm going to use Notebook LM to learn something. And so I went out and I searched a bunch of travel blogs that I would have never read. It's only 9 or 10. Still not going to read that many. Loaded them into Notebook LM. So this is the RAG. They take this. This is my source of truth. And number one, I can start asking questions against it, right? So I could come down here and I could say, what is the difference between a ruby and a tawny port? Words that I had no idea what they meant before going to Portugal. But what it does is it grounds it in these. It goes out and it creates a response. And again, the citations are here. So you can see exactly what source that came from and what it pulled out of that source to create the response for you. So you can query against it, you can learn, you can ask questions about it. But this is probably my favorite part, is that sometimes reading and tokens into my brain I just want to listen to something, right? And so it creates this podcast.
Get ready to say, Olá, de Porto. We're diving deep into this captivating Portuguese city in the Douro Valley. You've shared some really amazing articles with me, and I've got to say, I'm already feeling that wanderlust. Yeah. Cobblestone streets, the aroma of pastel de nata just wafting from bakeries, centuries-old architecture. It sounds absolutely magical.
Oh, it truly is. And what's fascinating about Porto is that it offers this incredible blend of youthful energy, and then this.
So that's just one example. Let me run through just a couple more that we did. I had to do a lunch and learn for Dennis Madsen, and over at City Hall, he's in charge of, what is he in charge of? Zoning and ordinance. Yeah, city planning, zoning, and ordinance.
How many source documents can you upload?
300. So you can create a massive amount, and it's multimodal. You could put YouTube videos, you could put images, you could put PDFs, you could put, so you could create your own notes to give it additional context and say, use that as an article. But one of the things I did for them is, okay, let's put zoning and ordinance. They're technical people. If you look at it, they've got paper books that are dog-eared, and they've got sticky notes in them because of places they reference often. You could come in here and you can query it, and let's say, hypothetically, I want to, if I spell that, to open a brewery in Huntsville. What zones am I allowed to build in? Right? Me is just a Joe Schmo that knows nothing about city ordinances. I'm just a person with an idea, a business plan, and I'm like, where do I start? Let me just load this document. Lo and behold, it tells me I can build in C3, C4, C6, light industry, heavy industry, and I can start having follow-up conversations. What do I need to be worried about in my design first? You start having a conversation. What was fascinating is that the mayor, of all people, grasped what was going on before anybody else. He said, you're meaning to tell me that I can take all of my city council minutes, load them in for the last 10 years, and I can ask a question of how many times we've talked about street sweepers, and it'll tell me exactly when, and I said, you got it. So the mayor got it, 100%. So being able to load in all of your reference documents and query against it, just start having a conversation with your data. It's massively, massively powerful. So
it's only based on the data that you
yes,
upload. So
correct.
The truth
Yeah.
is basically whatever you.
Yes, it's grounded in truth of what you've loaded in. Yeah. So here's one more example. I was going to go through one, but I'll just say it here. In colleges, I read that what they're starting to do is they use their phone, they record the audio of the lecture, they take the lecture notes, they load the two of those into Notebook LM, and they say, summarize salient points. They say, make me a quiz, and they say, make me a podcast. So my daughter started doing this. She's a freshman at Auburn, started doing it with her, she did it with her psychology exam studying. She said it's game-changing. And so what I did is I said, you know what? I'm going to record the audio from our good friends Booz Allen that did the panel discussion, hour and 20 minutes. I'm probably, if somebody said, hey, I've got an hour and 20 minute thing for you to listen to, I'm probably going to say thanks and probably not listen to it, right? But if I come in here and I say, let's generate a podcast on it, and let's see what it does. And you can customize it. So I can give it what I want it to focus on. Generate a informative podcast focusing on the concepts, not the people. Okay, and I hit generate. It's going to take a minute to generate. It's done rendering. It's going to take 1 second to load in, and let's see what it says. Okay, it created a 14-minute podcast about the Booz Allen panel discussion. I would probably listen to a 14-minute, especially on 1.5 or 2, if somebody sent me that. So no, I mean that's what people are doing now in our company. They're like, hey, we got this Gartner report that says this. I've already loaded it in Notebook LM, and I've already created the podcast. Listen to it, and if you want to do it, then go dig into it. So it's actually a great way to share information within your company.
Welcome to the deep dive. We've got some really interesting stuff to go through today, all about AI implementation. You sent in some insights from Booz Allen Hamilton experts, and there's a lot to unpack. Panel discussions, real-world examples, even some thoughts about what the future might look like with AI.
It's a fascinating collection. I think it really gets to the core of what AI actually is, stripping away all the buzzwords and hype. And then we can get into how to actually use it, whether you're running a company or just trying to optimize your own life.
Yeah,
So this was just a side project that 10 engineer at Google put together, and it caught fire. So now it's one of the ones they're putting a lot of energy behind it to really blow it out. And so one of the things they've got is interactive mode, is that you can start the podcast, and if you got a question, you can interrupt it and ask your question as if you're in class, and it'll start answering it. So you can start interacting with the podcast if you're like, wait a minute, expand on that, tell me more about that. So this is a tool that I think in the next 6 months is going to be, Google's going to be, this is a good one that's actually making the use case for a language model very relevant to a lot of us. So there was one more, this one. So this is the one that I took, I just went online last night and I found an open lecture on MIT. It was a psychology. I took lecture number 7 that had the audio and it had the notes just to simulate what you could, or what you should be telling anybody that's in college right now of how to continue to study and reinforcement learning. But they've already got automatic buttons for you. So if you wanted to make a study guide, you just click the study guide. I know, no kidding, man. If we had these tools and go back, just have somebody. You don't even have to attend class anymore. Just have somebody attend, record the lecture, bring it back, share the audio, and then, yeah. So this is based on the information, it was like, here's the quiz that it created, 10 questions, and then they give you the answers down here. So you can really test yourself, and you can ask it. You can redo it over here and say, make them multiple choice questions, or make them true or false, or make whatever you want to do. It'll respond and do whatever you ask it to do. It's pretty nice. Let's see, did I have any other examples that I wanted to hit with Notebook? All right, let's talk about reasoning models. So we just talked about RAG. RAG was a way to give us more trustworthy information. Reasoning models. Okay, this is interesting. So there's a couple different scaling laws that go into these language models that you hear about. One of them is the number of parameters, right? GPT-3 was 200 billion parameters. GPT-5 is going to be 5 trillion parameters. Well, it turns out we're starting to hit an upper bound on the amount of information that we can stick in and what expanding model size actually does for us. It's not giving us any actual deeper insights. But what a different dimension of scaling law that they realized is they said instead of doing one-shot token prediction, and you remember when we did that OpenAI and it looked like it was just a typewriter writing words for us? That was like one-shot prediction of what the next token should be, and it was generating nice text. What they learned is they said, hold on, if we give the models longer to think. It's called inference time. And if we let them think longer and we give them some special instructions along the way to really think about what they're doing, performance went way up when they started giving the model longer to think, which is a lot like humans, to be honest with you, right? I mean, so that's pretty interesting. So there's two different dimensions now. There's model size and there's inference time. And so these reasoning models, step-by-step reasoning, explaining their outputs, I don't know. There's a lot of things that are baked into them. There's not a cute little picture to go along with the reasoning models. But for example, this would be something as a professor I would be upset with. Yeah, I'm going to go to the O1 model now. All right, so what I'm going to do is I'm going to pretend like I just took a picture on my phone of, well, I'm going to show it to you guys first. Okay, so I'm a complete nerd. I was on the math team all through high school. All the international Olympiad math competitions, I had every book, I have everything, right? And so I went through and I just said, I'm going to take a picture of a math problem that was from one of the math Olympiads, not a very easy question. I'm just going to throw it in the reasoning model. I want to see if it can answer the question. So when you do that and you load it in, see, I just loaded an image. You could take this straight from your phone, straight in the app on your phone, and then I don't even have to say anything, or I can give it some instructions. Solve this problem. Now, as a matter of fact, okay, did I write down, actually I had some, nope, I didn't write it down like an idiot. I pretended like I had to explain this to my son who's in high school, but I wanted him to think that I knew how to do it, but I really didn't know how to do it. So I need to explain this, the solution to my high school daughter. But I don't want her to know I don't know how to do it. Okay, so I can do that. And again, I'm giving the prompt a lot more context so it knows what it needs to give me in the output. When I ran this last night, it actually took about 90 seconds to run, so it might be doing this for just a second or two, but let's see if it does the same as it did last night. Okay, here we go. Here we go with an answer. So step by step, it tells me what to do with the triangle, and then it tells me what to do between those 2 points, and then it says you got to do these equations. And then they say there's some similarities in the triangles and something actually divides out. And then lo and behold, yeah, the angle 72, yeah, your answer, the exact choice is 1/5. So completely solved the math problem for us. That was, a national level math competition math problem. And so what is O1 doing with its reasoning model? So number one, it uses a chain of thought, which has specific prompt instructions along with it, or tree of thought, which is basically go down 7 different paths. On top of that, it's got a bunch of smaller models that are industry specific. So they link up with Wolfram Alpha. Wolfram Alpha is a math engine that's solved everything. And so they use natural language, they set the problem up, they start going down a thing, and then they put the problem into Wolfram Alpha and they get those results, and then they put them back in and give you a rendered answer that makes a lot of sense. All right. One more thing, one more tool, and this is a paid tool, what I'm going to show you. But I'm getting an enormous amount of quality out of it. So it's Gemini 1.5 with deep reasoning. Okay, so what deep reasoning does is it goes through that reasoning chain of thought, but it gives you a detailed report. Something that a Deloitte or Gardner, of course we're not paying $50,000 and the reports are going to be a lot higher quality. However, it gives you a 60% Deloitte-ish type solution for just what, and it does all the web research for you. So I think I had one here. Yeah, So as a manager, many of us have probably had this same thing. Let me paste it in here. It says, I am in the process of hiring a new generative AI, machine learning, data science engineer in Huntsville, Alabama. Can you help me research the mean and median salary for this position? I am looking for an engineer with 3 to 5 years of experience. First thing that HR is going to ask you is, I don't know, what's the salary range? And you're going to go, I don't know, let me go look it up. And you're going to go to 1 of 2 sites. But what's really nice about this robot is now, especially using deep learning, is it tells you, okay, here's our problem. Here's what I'm going to do. Let's click more to see exactly what its chain of thought in its research is going to be for us. So number 1, it's going to find the salary data for a Gen AI ML data scientist in Huntsville, Alabama, 3 to 5 years. Find one in the southeast region, so that's probably good corroborating information there. Find salary within the US, so it's going to kind of walk itself up. And then it's going to look for just data science in Huntsville because they know data science is adjacent. They're look for mean and median, information about cost of living in Huntsville to also kind of gauge what it is. So I would look at that and go, that looks like a pretty sound. But if I wanted them to do an extra step, I could tell them right now. I'd say, can you add step 6? And give it some instruction, and it would add it to that. But I think this looks pretty good. So I'm going to say, start your research. Okay, and again, these take a minute, but it's showing you, it's kind of like building that trust of what's going on, right? It's like, okay, I can follow what's going on, because watch, pretty soon it's going to populate like 13 websites.
And that's Gemini what?
1.5 with deep research.
So when we Google stuff, I mean, at the top, there is a little
Yeah.
blurb, right?
Yep.
It's kind of the back end, or it's probably not the pro deep research I would
It's
imagine.
probably not deep research. It's probably Gemini 2.0 Flash that they're just doing a very quick summary. You notice that's why I went to DuckDuckGo to do the web thing, is because Google's already doing web summarization on your query. So they're already building it in. So I had to go to DuckDuckGo, who's not doing it, which is just websites. Yeah.
Is this, you said this is a paid service, how much does this cost?
$20 a month. Yeah.
How much money are you spending on generative AI experiences across the board?
It's like, ask me how many streaming services that I've signed up for. I mean, what's, I don't know, more than I should probably, you know. So I mean, look at all the different websites that it's pulled from, right? I wouldn't spend the time and go read every one of those and doing the research just to come up with a salary analysis for a position that I'm hiring. But I'm glad this robot wants to go read those 27 websites so far. And look, it's not even done. That's the first 25% of its research.
Can you stop it?
You could stop it by hitting the stop button, but we're going to let it roll. Okay, look, we have our document. It's fully rendered. And so we go through, and it's like, wow, okay, salary data, 115, 93, and look, they reference everything for us, so we can see, we can go check the websites. Scroll down, Southeast region, here's the pay scale, US nation, Microsoft does this. Data science, the adjacent one, here's the mean salary. They give it to us like this. Cost of living. I mean, this is a very nice detailed report that in conclusion, it does this. And I can save that, I can open it, save it in my Google Docs, I can turn it into a PDF, and I send it to my HR people, and I say, this is the position I want to hire, and here's the salary, and here's why. And they go, wow, okay, good. That's just one example, right? I mean, so how many other examples? You just throw an idea, throw it a concept. Oh, let me show you the one, let me see if it's done running. I think I actually broke it, because I started it last night. I read somewhere of, yeah, let me see. Okay. It's still running.
Can you get them to write poetry?
Oh yeah, you can have, see that's kind of the, you could say, I could have said, write that report in Old English, Shakespeare language, and it would have done it, and so it knows that. I wanted to see if it would do this one, and it's still running 18 hours later. Create an NCAA basketball-style bracket of the fiercest animals on Earth. Play the bracket out and tell me which animal wins the bracket competition. Assume the animals play a home and away series on their native living environment. And it's up to 349 websites that it's scraping to get all the animals in there.
Can it make you a movie?
So I don't know. I mean, I'm waiting to see if I've really broke it. I mean, let me see if it's blinking at the bottom to say, wow. Yeah, it's still thinking. Look, I mean, those things are still pulsing. They're still, so 18 hours later, it's still doing deep research for me about who would win my fiercest animal NCAA bracket. So anyway, it wasn't this is, let's see, where are we? We're about done.
So Larry, can I ask one sort of neophyte question?
Yeah.
where is the compute power coming from that you're keeping occupied for 18 hours?
Yeah.
Right? And you know, like, can you crash a system? Like if you get a bunch of users?
No, it's all cloud-based now, and they've got this very, very well managed. But you raise a really good point. These language models are so big, so broad, that we have to submit our data. It's got to go up to the cloud. It's got to do the inference processing. It's got to get our response, and then it gives it to us. But what do you think Apple's waiting on? Apple, who's the king of privacy, who has been way behind in everybody and just sucking in this AI game, they're waiting for the models to get small enough that they can put it on the edge device and run it on the edge device. They want Siri to be running natively, so you're not passing any private information or AI, you know, it's air gapped, it's completely locked. So, but I mean, that's also what NASA's looking for. If I've got a mission to Mars, I can't radio back to Earth to say, hey, cloud computing, can you give me this answer, 8.5 minutes away while I just punctured myself and I'm dying. You know, I need to know right then and there how to tourniquet myself or whatever's going on, right? And so that's the models are massive and they take all this compute to run, but the idea is to scale them down, 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 down. And that's what DeepSeek has done. So finally back to DeepSeek, which everybody, I don't know if you've heard anything in the news, DeepSeek, Chinese model came out. They focused, instead of building a huge parameter model, they said, we're going to build a small parameter model, but we're going to just do this reinforcement learning and just see what we can get out of that. And they scaled it, and it's performing almost as well as O1 Deep Research. And 1/20th of the cost. And they put all the model out for free. So you can download it, and you can run it on your own devices, and you don't have to pay OpenAI a penny. So it's kind of shaking the entire market. It's kind
of capturing your data.
If you go through their web portal to use it, yes. If you download the model, you're downloading weights. All you're doing is downloading a bunch of floating point numbers, and you're running it yourself, so you're air gapped, you're contained. So they aren't getting your data if you're running it locally. But if you're running it through the website, the portal, they're taking every bit of it.